All right, grade 12s. So here are a few examples to help you with those prerequisite skills assignment that you got today. I'll leave out A, B, C, but in question 1, we'll just work on D here. It says for each function identify the following: the vertex, whether it's a max or min, the axis of symmetry, etc. So we've got this in D, we have this equation, but it's not written in that vertex form. So we need to start by completing the square. To start with, we need to factor out that negative 1/3 from the first two terms. When we do that, we're left with x squared minus x inside the function, and then minus 2. So we factor out the negative 1/3 from the first two, so the negative 2 is left by itself off the side. Then we complete the square inside here. Remember, to do that, we take half of the coefficient of the x term, so negative 1, which half of that is negative 1/2, and we square it, which gives us positive 1/4 and minus 1/4. So we have to add the square of half of the linear term. So we add it, we subtract it, and then we take that negative 1/4 and we take it out of the bracket. When we do that, we think of negative 1/4 times negative 1/3. That gives us positive 1/12. We combine that with the negative 2, which is like saying negative 24 over 12. And that gives us negative 23 over 12. And we factor this perfect square trinomial, to get x minus 1/2 squared. So that leaves us with f of x equal to negative 1/3 x minus 1/2 squared minus 23 over 12. And with that, we can answer the questions now. So the first one was, what's the vertex? Well, the vertex is going to be based on this x coordinate and this y coordinate. And it's going to be to the right 1/2 and down 23 over 12. Since our function is negative, then that means our parabola is going to be pointing downwards, so it's a maximum. That vertex is a maximum. The axis of symmetry is always found here. It's based on what the x-coordinate of the vertex is. So x minus 1/2 means the vertex was moved to the right 1/2, so our axis of symmetry is x equals 1/2. The direction of opening, since we have a maximum, the direction of opening is down. And the domain and range, well, it's a parabola, so the domain is the set of all x's such that x belongs to the set of real numbers, or is an element of the set of real numbers. And the range is all the y's such that y is less than or equal to whatever my maximum value was. And my maximum value in this case was negative 23 over 12. Question 2 is similar to what we just did. We took this function and rewrote it in vertex form. So I'm going to do that right now and then come back. So like we did in the previous question, we factored out the leading coefficient, 5, from both terms. So that left us with 5 times x squared plus 8x, and then minus 27. Then we took half of the linear term and squared it. So half of 8 is 4, 4 squared is 16, and we added and subtracted that inside the brackets. We left the 27 alone. I took the negative 16 out of the brackets. When I do that, I have to remember to multiply it by positive 5. And 5 times negative 16 is negative 80. Minus 27 gives us negative 107. And that perfect square trinomial is always going to be the square root of the first term, which is x, whatever the first sign is, plus in this case, and half of the coefficient of the next term, so 4. So I get 5 times x plus 4 squared minus 107. So that's writing the function in vertex form. Now they want us to graph it. So I'll just set up a set of axes here. And you'll notice because of our minimum, or the y-coordinate of the vertex is negative 107, I set my y-axis up a little differently than my x-axis. So I want it to go down fairly quickly. So just eyeballing it here, this means my vertex is back, so back 4, down 107, and it's going up 5 times as high as it normally would. So if I went over 2, normally I'd go up 4, but I'm going to go up 5 times as that, which is 20. So roughly about here. and here. And then if I go back 4, normally it'd be 16. 5 times that is going to be about 80. So roughly here at 27, I believe, and 27. And I've got a parabola coming up like this. Label the vertex and the x-intercept. So the vertex is going to be -4, -107. Find the x-intercepts. I want to let y equal 0. So if I go 0 equals 5 times x plus 4 squared minus 107, I'm going to move this over. That gives me 107, and divide by 5 is equal to x plus 4 squared. If I take the square root of that value, so when I take the square root, I'm going to get a positive and a negative number. Then I'll subtract 4, and that's going to tell me what my x values are. Next, we're looking at absolute values. So just a reminder that anything that's inside the absolute value symbol, we calculate it, and then it comes out positive. So this is like saying -6 plus 3, which is -3, plus 4 times -3 over 2, which is -12 over 2, which is -6. And -3 becomes 3, -6 becomes 6, so we're left with 9. So just follow order of operations, work inside the lines, and then whatever value you get, spit it out as positive. Now, when I graph something like this, we're graphing the absolute value of x squared minus 5. When you graph y equals x squared minus 5, that's just a parabola with a vertex at 0, -5. That's a parabola that's been moved down 5. When I take the absolute value of it, all that does is take anything that's below the x-axis, anything with a negative value, and make it positive. So taking the absolute value of this graph takes everything that was below and brings it up. So now the absolute value of x squared minus 5 is what's in red. That's it. Anything below gets reflected up. Now, to solve this graphically, we need to graph this portion of the equation and this, and then we just find out where they cross. So 3x minus 7, if I graph that like a line, it's got a y-intercept of -7 and a slope of 3. So I graphed a little bit of a dotted line here below the x-axis because I know that that's going to get reflected up, and then I continued up. I took these key points, plot them above the x-axis, and then I just keep drawing my graph up through here. So that's the left side. That's the absolute value of 3x minus 7. X plus 1, let's do that in a different color here. X plus 1 has a y-intercept of 1 and a slope of 1, so it's going to go up 1 over 1, up 1 over 1, etc. Let's see, 3, and so it's going to intersect here and here. So when we solve the equation algebraically, we look at two cases. We look at when 3x minus 7 is positive, over here, and we look at when 3x minus 7 is negative. So I multiplied that by -1, and that gives us this. So that's just simple. We just get the x's together, get the coefficient, the constants together. So I subtracted x, get 2x equals 8 when I added 7 to both sides. Divide both sides by 2, and x equals 4. -3x plus 7 is equal to x plus 1. I bring the x over, that gives me -4x. I bring the 7 over, I subtract it, that gives me -6. -6 over -4 is the same as 3 over 2. And if you look back at the graph, even though my sketch isn't all that great, we can see that over here we had an x value of 4, so that confirms one of our solutions. And this other one is between 1 and 2, and 1.5 looks reasonable. 3 over 2 or 1.5 looks reasonable. So the last question is to graph the reciprocal of a function and then identify the vertical asymptotes. So let me set that up for you. So when I graph the reciprocal of a function, I like to graph the original and then work with the, or how to graph the reciprocal. So the original is x squared minus 16, which gives us this parabola, a vertex of 0 and -16, and then over 2 and up 4, over 4 and up 16, over 6 and up 36. So we've got that graphed. Now, anytime I want to graph the reciprocal, I start by identifying the the zeros. Where does the graph cross the x-axis? Where's y equal to 0? Right here on the x-axis. And that's where I'm going to have a vertical asymptote. Right through there. It's a vertical line that my reciprocal function doesn't cross. Then I look for the positive and negative ones, values that are at a height of positive and negative 1. And on here, because of my setup, they're going to be a little harder to graph, just because I'm sort of zoomed in a little bit. Those are invariant points. Whether I go 1 over 1 or 1 over negative 1, it's still going to be equal to that value of 1 and negative 1. Then I look for convenient points to take the reciprocal of. 4 becomes a quarter, which is really close. 1/2 over here becomes 2. A little tight to graph here, but essentially my graph is going to look like this. Coming up, never touching the asymptote, and coming down like that. Again, never touching the asymptote. Underneath, this point of negative 16 is going to be at 1/16. Well, this is negative 2, that's negative 1. You can imagine that negative 1/16 is very close to the axis, the x-axis. And that's going to come through here, through that invariant point, and then turn sharply down towards the asymptote. Okay, so tough to see here on this graph. If we zoomed it out, it'd be a lot better. That's it. So take a look at this, work through as many of those questions as you can. If you're limited in time, do a few of each of the questions instead of working through all of 1 and 2 and leaving out 3, 4, 5, 6, 7, 8. Okay, bye-bye.